Hi everyone, this is Ornella, aka Side Project Queen, coming at you again from Amsterdam with my dog Pixie. So, I've been working on a lot of side projects as always, and the one I had been recording was migrating my data off of Google Photos to a self-hosted solution. I ended up just like putting that on the back burner and recording this video instead because it's a little bit more timely and people have been asking me for it. And I realized that's kind of like the catalyst for these videos is when people ask me to record it. So this video is going to be about the talk that I gave 3 weeks ago in London. And this talk I gave at this event organized by She Bytes Back. She Bytes Back is an organization of women in tech run by Amber Shand, who's an absolute force of nature. This event was 3 talks. I was the third talk, and the room was about 70 plus women, senior women in tech. The Q&A ended up being the highlight, was just everyone just starting to share their own opinions and their own, you know, hot takes, questions. There were amazing points made about governance, about productivity, about metrics, about how to measure that kind of progress, about learning, the place of learning, mentoring. I mean, it was such great energy. I really don't say that lightly. Without further ado, let's talk about judicious LLM usage for your wallet and the planet. There's a lot of talk about how to make AI more powerful and how to harness it to its full potential. Today, I'm going to talk about how to optimize that usage, how to make it more efficient, which is good for both the planet and the wallet. The plan for today, first, I'm going to tell you a little bit about myself and why you should care about this. And second, I'm going to talk about the things that LLMs are good at. Third, the things that they are pretty terrible at. And fourth, my tips that I've learned through usage of these technologies to burn the planet a bit less. So a little bit about me. I'm a staff software engineer. I'm a fractional CTO. I'm also a bootcamp grad. Shout out to all the bootcamp grads. Graduated from a bootcamp, coding bootcamp in 2019. My capstone project was actually thanks to my colleague who was really into AI, was a neural network to predict a user's mood based on their past activities. And yeah, it was something that kind of sparked my interest in data and AI, but I didn't actually use LLMs or use AI as a tool for coding until 2022. 2022, I think, is when GitHub Copilot got released into beta and then like full access. And at the time, it was basically glorified autocomplete, which was great, but we know what autocomplete is, right? Um, in 2024, I would say is when I started using ChatGPT, Gemini, and Claude. The first major usage that I got from these was SQL queries. So I'm not a data engineer in the same way that Super Hot Fire is not a rapper, meaning I have to write quite a bit of SQL, but it's not necessarily my bread and butter, and I don't really have any interest in getting very good at it. And therefore, having a tool where you can just like ask, hey, how do I do this particular thing in this particular database? And it just spits out something that's more or less correct. And then you can feed it the errors and refine it. That was super useful. I also used it for research with Perplexity, and I identified like some pros and cons, and also for tech spec reviews, for drafting, etc. It was essentially at this stage like a helpful assistant. And then from last year, 2025 to now, um, it was all of the above plus suddenly agentic AI. And that was really a game changer. I started using Claude Code and Cursor and started doing sort of like hands-off iteration. You could do looping, and there's MCPs to integrate external and internal tools. I recently built an MCP for internal usage of the company's own REST API to do like smoke testing and things like that. And essentially, it gets to a point where the AI is like close to autonomous, right? Um, and all this is amazing, but there is a very real limit, and that is the cost, the environmental and the economic cost of LLMs. LLMs, large language models, are basically the technology at the core of most AI tools that we use currently. and they are very energy intensive. That energy basically means a lot of water usage, a lot of space usage, a lot of emissions of carbon. Essentially, this is very bad for the environment. So training from the sources that I've read is usually the bulk of the energy cost. There's no like publicly available numbers for like all of the LLMs that have been trained out there, but that's what the articles I've read seem to suggest. You could think of it, if we have this like metaphor of like build time and run time, right? Like this is sort of the build time, the time that like these LMs are being developed is ingesting immense amounts of data and refining these models. A model like Opus is basically ingesting the entire internet. That takes like tremendous amounts of compute, right? And that is extremely, extremely energy intensive. And then what we're going to be concerned about today is the inference stage. And inference is basically runtime, or like it's the ongoing usage of the LLMs. Um, each chat GPT query, I think some Altman said something like it is about the same as like 2 seconds of using an oven or something like that. That means absolutely nothing to me. But it heavily varies by model, it heavily varies by types of questions. All you can know is like this is also quite energy intensive, especially in comparison to most other programming. And currently, inference is still heavily subsidized. So if you're paying like $20 a month for like Claude, for instance, um, it's suggested that these subscriptions can cost like up to 13 times as much if they were on a usage-based model, because basically like all these companies are trying to get us to, or are trying to like corner the market, and therefore they are subsidizing the usage. But yeah, inference is actually quite expensive as far as energy consumption. The move to usage-based pricing is underway, and it's about to get a lot more expensive. So even if you don't care about the environment, the actual environmental costs are about to be a little bit more visible to the user. So if we want to talk about how to optimize LLMs, let's start with how LLMs work. So on the screen, I put up this tweet that was really foundational to my consciousness as an adult, from the golden age of Twitter 9 years ago. I'm not going to read it out loud because I'm a consummate professional, but I think it's something to keep in mind, right? LLMs are, when we are using an LLM, we are just prompting the text bot for text. LLMs take in text as natural language as an input, and they run it through a series of very complex probability-based algorithms to output text that is most likely to satisfy you, right? That has been ranked as the highest probability of being a satisfactory output. You're prompting the text bot for text. Sometimes I talk about this, and I think this framing can be seen as reductive, but it's really not reductive when you think about the amount of things that that is actually really great for. And from my usage of LLMs, these are the main sort of areas that I've identified. I would say it's like summarizing, translating, and filling in the blanks. So there's a few use cases that that's amazing for. For example, rubber ducking, right? Like if you rubber ducking is like this practice. I'm sure most technical people are familiar with it, but it's like if you put like a rubber duck on your desk and you explain to it what you're about to do, just the action of like saying what you're about to do and saying it out loud, um, pulling your thoughts out of your brain can already be quite helpful. If you're doing it with a person, the advantage is that this person might actually like learn something and like give some good output, is quite helpful already. Also because it's really good at repeating your thoughts back to you in a slightly different way, right? So the second thing is generating tests. If you have ever done test-driven development, that is something that just because of the syntax of writing tests used to take me quite a long time. And it's something that's really at the sweet spot of like very predictable and also kind of like syntax heavy. And LLMs are really quite good at writing unit tests in my experience. They're also quite good at generating code for common use cases, again, because of like how training works, right? If there's a lot of like training input for something, the response is likely to be like pretty accurate. Um, Fourth, translating across languages. I think like portability of code across languages has improved substantially since releasing LLMs because again, like they're basically doing the like translating thing, like or transposing of this particular syntax into this particular syntax. There's some limitations around like not all languages work in the same way, and like there's times where, you know, I've done this and then turns out like the new implementation in the new language is completely inefficient because it's not using the new language or tool properly. But still, like the barrier is way lower. Um, LMs are really good at parsing logs and errors, really identifying like in a 500 stack trace, 500 line stack trace, what is really important within that. And finally, something that we don't talk about enough, in my opinion, is they're really good at making you feel good. Okay, so last year, I think it was, this study came out that had two groups of developers perform the same task. The first group was using no AI tooling, the second group was using Cursor, and they had them again do the same task. And the first group was, I think, about 20% faster, and meaning the no AI group was 20% faster at completing this task. But interestingly, the group that was using AI felt like they were actually about 25% faster than they would have been at otherwise. I have my issues with like the way that the study was performed. Notably, like some of the group that was using Cursor had never used Cursor before, and I think just like the learning curve might have like slowed them down in a way. But more than the time to actually accomplish the task, I think is really relevant that most of them felt like they were faster. And that's something that I think is under discussed is like, you know, coding can be a very emotionally frustrating experience. You can be like banging your head against the keyboard for, you know, hours, days, weeks sometimes, trying to find the solution to a problem. And you can feel sometimes like nothing is happening, and it can be kind of like lonely, right? And I feel like when we're using LLMs, there's like quick feedback. There's stuff happening on the screen. You feel like you're making progress because stuff is happening, whether the code is accurate or not, it's being written. And and I think that that emotional experience plus like obviously the mental load that is being taken away because like translating your thoughts into code used to be something that we have to do way more, and now because we can feed natural language into this model, and there's less mental load to do that, right? So those are already things. And then of course commercial LLMs are built to, you know, create a certain emotional experience for the user as well, right? I used to joke that like Claude tells me I'm right 17 times a day, and that's something that no boyfriend has ever done for me. Generally speaking, the UX of LMs is quite good, and that's something not to underestimate. You know, sometimes you need that. But now here are the things that LLMs suck at by design. First is giving a precise and predictable output. If you ask an LLM what's 2 plus 2, you know, just an LLM, I'm not talking about like an agent that can run, I'm saying just an LLM, it's not going to run a calculator. Is going to take that text as an input, is going to run a series of probability-based computations, and is going to output some text characters that are likely to satisfy you as an answer. So an LLM is always guessing, right? And that brings me to the second thing is like an LM is not able to know anything that a human can't know by reading. So basically, if something is not in the documentation for something, if no one has written about something, the LM is just going to give you a guess, and this guess is likely to be erroneous because there's simply no data for it to tell you that. So brings me to the next point as well, which is citing their sources. LLMs, because of the way that they are trained and the complexity of the probabilities, like no one is able to tell you exactly what the probability algorithms are in an LLM, the computations are. So they're really bad at citing their sources. They don't know if the source is like what they just like ingested 2 minutes ago, or if it's something that was from the training like a long time ago. This is not what they're built for, right? They're also not very good at communicating their certainty. So these are probability-based algorithms, meaning the answer that they give you, I believe, probably is first in a series of ranked answers, right? They could tell you, hey, here's my first possible answer, here's my second possible answer, here's my third possible answer. But generally speaking, they don't do that. And they also are built with a commercial purpose, usually of sounding very confident so that you keep using the product, right? So they usually sound like overconfident. We've all experienced that. Finally, and the most under-discussed thing, in my opinion, is these are text generation algorithms. They're not text deletion algorithms, meaning for refactoring text, for reusing text, this is not what they're built for. You can ask an LLM to build you some functionality, and they're gonna re-implement the same thing 100 times before they think of using an abstraction. And all this brings me to my tips and tricks, how to use less compute. So I would put those into two buckets. The first one is avoidance or triaging. So, quick anecdote time from work. So, I work at this company that does basically data pipelines. And what we do is we take our customers' data and we ship it, send it to um, their consumers, their customers, basically, who are consuming this data from a bunch of different data warehouses or cloud, etc. And in this particular case, the data that was in the data warehouse was not able to be consumed by the consumer. So we went in with SRE, I went in with SRE, and we're on the call and we are running some SQL queries. And after running a series of, I think it was like 5 or 6 SQL queries, we identified those are the ones that we need to run in this sequence to fix the one table. And there's like 20 tables that are broken. And we're like, okay, now we're gonna have to run this for 20 times. And so the head of engineering slash product is on the call and he's like, okay, I'm gonna craft you guys this perfect chat GPT prompt and it's gonna output you the SQL that you want. And he does, and then he bounces off the call because he had other things to do. And and so we try to make this prompt work, but every time the output is like, it's just slightly different. It like corrected the name of a table and it slightly changed this and it's truncated. And you're like, can you give me like, it's like, hey, here is the first 10 and then etc. Like you just run the same thing for everyone. It's like, no, no, that's what I'm asking you. It's like, I'm not asking you to do the first 10. I'm asking you to do all of them. So we try and we try maybe 5 or 6 or I don't know, a lot of times to make this ChatGPT prompt work. It's just not working. And I'm like, you know what? Let's just do this in Excel or Google Sheets, right? So I paste the list into Google Sheets. I paste the first statements that worked for this first output, and I asked the little built-in AI agent Gemini, hey, can you take this list and these statements and give me a formula that will just like replace the names um, and give me this series of statements. And it did that in like 2 seconds. And then we just used that. And then the head of engineering comes back and he's like, hey, so how did it work with the prompt? And I'm like, oh, we ended up uh, using Google Sheets, but I asked Gemini to make me an Excel formula. And he's like, oh, so you gave up on the AI? And I said, no, I didn't give up on the AI. I just used the AI to do something, to do what it's good at and let an Excel formula do what it is good at. So, yeah, generally speaking, and you can quote me on this one, if there's one thing you can take away from this talk today, is that using an LLM for something that an Excel formula can do is like leaving your fridge open at night so that you can see. It's not only extremely energy inefficient, but it's also way less, way worse than just turning on the light, right? So just don't ask an LLM when some other tool is better. For research, you can sort of ask yourself from that list of things that LLMs are good and bad at, is this publicly available info? Do I care about the accuracy? Do I need the primary sources? Or for code, does this code exist elsewhere and can I reuse it? Can I create an abstraction that is going to use instead of letting it go wild? Can an Excel formula do it? And if so, use an Excel formula or like some other knockoff like Google Sheets. Can a bash script do it, right? If a bash script can do it, use a bash script. The um, the second one is avoid a smart model when a dumb one can do. So say you needed a list of 10 animals. Why would you ask a PhD zoologist when you can ask your 6-year-old niece? Commercial AI companies offer a variety of different models that you can like just click through at any point, right? Like when I'm using Claude, most of the time I'm using Haiku by default. And then once Haiku hits a wall, then I upgrade to Sonnet. And then rarely I actually have to upgrade to Opus. But generally speaking, like for most usage, there's no reason for you to like go to the latest and greatest and the most powerful. Just pick the cheapest and most efficient until you hit a wall. And finally, I have not personally done this, but one way to approach it as well is to run LLMs locally, because then you're limited by the power of your own machine. When you hear the fans whirring, you know that what you're doing is pretty computationally intense. And also those compute costs are going to be on your electricity bill. They're not going through the cloud and like the networking, etc. Which is in itself a little bit more efficient, but also just like you're gonna feel that burn yourself. So the second bucket is what I would call optimization. So now you are using an LLM. How do you make it better? And there are basically two levers you can pull or two buttons you can push to optimize your LLM usage. And the first is reducing the context, so reducing the input that the LLM is working with. And second is increasing the accuracy, so making sure that the output is more accurate so that there's like fewer iterations and therefore fewer queries, less compute. The first one I would say is reusable tokens or avoiding single use tokens, right? When you are doing something that you know you're going to reuse, instead of having the LM figure it out every time, just output. I prefer to do a bash script. You could also do like a Claude skill or something. I think bash script is nicer because it's just like, tool agnostic. But you could also do like a markdown file. You could do even like even better, some sort of testing or debugging tool or harness that you can share with your coworkers who are on this code base. Um, and that way, even you can run this script or these tests without an LLM next time. Or if you're using an LLM, it's going to be like a lot faster because it's not figuring it out on its own. The second thing is keep things dry and clean. So less code means more consistent code and means less context to ingest. And also fewer places to updates means less drift, less room for error. And finally, I'm kind of going through these a bit more quickly because I think there's a lot of information on this particular point. Is like testing and documenting and guiding your usage. So like creating Claude skills, creating agent documentation for Claude, creating just generally documentation of your code base to help the LLM figure out exactly where to go, instruction documents that reduces the context, and it increases the accuracy of the output. So, in conclusion, just walking away with a few points. First, LLMs are not always the right tool. So, if you're triaging your tasks and thinking about them, you can kind of figure out if and how you want to use an LLM, whether it's to actually output this or to point you at how to find this information yourself. Basically, just like triage your tasks upfront to even figure out if you want to use an LLM and how. Second, LLMs are very powerful, especially on the market now. Even the open source ones are, and even the cheapest ones and the least compute intensive are excellent for most usage. Like 5 years ago, this stuff would have blown your mind, right? And now we're just like, it's really good already, okay? It's really good. Third, LLMs can help you build cheaper tools, which can even be reusable, right? So you can just harness the power of LLMs to build you some other code that is actually like way cheaper and way better. And then fourth, please save LLMs from themselves. We all know that the hardest part is not writing code, it's maintaining code. And if you let LLMs go wild, they're going to generate you millions of lines of code. And that just like is way, way harder in the long run. So save them from themselves, help them write less code, keep things dry, keep things clean. Don't let them generate code that they or you can't maintain. Thank you so much. And I hope to do this talk again at some point. That's about it. Thanks.